All right, we are going to get started with some more math. Yay! And today we are going to be talking about something that has to do with how a data set is spread out. In fact, we're going to call today's kind of lesson measures of spread. What does that mean? Well, we've talked about measures of center. If we say remember, measures of center. And that was kind of like the mean, the median, and the mode. Those are three different ways to measure center. And then we also talked about kind of shape. So we could say, remember measures of shape. And what do we know about measures of shape? We had bell-shaped. We had, uniform. We had bimodal. We had skewed. And then symmetric. And some of the things like bell-shaped and uniform, even bimodal at times can be symmetric. So that symmetric is kind of with a little asterisk because it can apply to any number of other measures. So that's kind of what we've talked about so far. So when we're talking about measures of spread, it's another way to kind of describe a data set. It's actually my favorite way. It's very telling, these particular things, because you can have a data set that's spread apart really wide like this. You could have data that maybe goes from like 0 to 100, but then you could also have data that goes from like 0 to, 40 or something. And obviously, the first example has data spread out further than the second example. So how do we measure that? The other thing that can happen is you can end up with kind of like picture a dot plot. We could have all of our values kind of line up right in the middle, and then we could get the average kind of, ending up right in the middle. But we could also have things kind of pile up on either side, almost like equally. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So let's make them equal. And then these two things can kind of cancel each other out, or kind of so that you end up in the middle somehow, right? So this is data here, and this is data, and this is data. Remember, the little X bar is the mean. So we could have, a mean equal another mean, but the data sets could be completely different in how they're spread. So that's what we're going to talk about today. There's three types of ways that we're going to measure spread. So let's say measures of spread. And I'm going to give you a data set to kind of work with. So here we go. We're going to use this data set: 0, 5, 10, 15, 20, 25, and 30. So we have 1, 2, 3, 4, 5, 6, 7 data points from 0 to 30. One of the easiest ways that we can measure kind of how spread out these data points are, notice I have these values in order from least to greatest. One of the easiest ways we can measure spread is with something called the range. So this is one way to measure spread, range. Oh. That's one way. And the range, kind of a definition for it, would be something like the highest value in the data set minus the lowest value in the data set. So in this particular case, we're kind of using our specific data set, we've got 30 as the highest value, we've got 0 as the lowest value. We subtract those two, we get 30, and that is our range. So it's saying our values in this data set kind of are spread out between a space of 30. If we erase the 0 in this data set, it'd be 30, take away 5, and then our data set would be only 25 points long instead of 30. But this is how we calculate range. Super easy. The problem is if you have an outlier, like if we added, 1,000 onto this, then it looks like if we took the highest value minus the lowest value, it would be 1,000, and it looks like, oh wow, your data is spread out really, really far. But actually, we aren't spread out that far. We just have an outlier. So we're not going to worry about this. And we're going to kind of say this is a way to calculate spread, but it can be distorted if you have an outlier. So what's a better way? A better way is something called the standard deviation. This is my favorite statistic. And a standard deviation, this is kind of the definition, like a working definition of what it means to be the standard deviation. On average, how far are we away from average? That's what we're asking ourselves. On average, how far are we away from average? Well, what does this word average mean? That word average is talking about the mean. Do you remember what the mean is? We kind of write it like this. That's the mean. And if we want to calculate the mean, we sum all the data points, sum all values, and divide by the number in the data set. So in this case, we have 7 data points. The number of data points. So if we're going to kind of calculate a standard deviation, we're going to have to calculate the mean because we want to know how far away each data point is from the mean. Kind of say, all right, are the data points close to the middle or the data points far away from the middle? What's going on? So let's calculate the mean. And if you remember how to do this, we're going to add all these values up. In this particular case, we're going to sum the values. So we're going to take 0 plus 5 plus 10 plus 15 plus 20 plus 25 plus 30, and that's going to equal something. I think it equals 105, but you should probably pause this and check just to make sure. And then we know that there are, what did we say, 7 data points. So we're going to take 105 and divide it by 7. When we do that, we should get 15. 15, in this case of our example, the mean is equal to 15. We did that. That wasn't too bad. If you're not sure about how to do this, go back and watch the lesson on measures of center. All right, so now we've got the mean, and we kind of want to know, all right, let's compare each value to the middle and see how far away we are. And remember, in mathematics, when you want to compare things, you have to use either subtraction or division. Those are the two operators we use for comparison. So subtraction compares things that are alike, like apples with apples, or, whatever, age with age. Division can compare things that are unlike, but we're not going to worry about division yet. We're going to subtract to compare each one of these values from the data point. So this is what we do next. This is kind of step 1. We find the mean. Maybe I don't want to call that step 1 because I already called something step 1, so we'll call this A. Find the mean. And then step B is compare each data point to the mean. The standard deviation is a lot of steps. I think it's like 7, maybe steps in particular to calculate it, and each step requires multiple computations. That being said, once you understand how a standard deviation is calculated, you can use technology to do it, but I don't like using technology first because no one using technology gets an understanding of what's actually going on. So I'm going to do it by hand, the old-fashioned way. Compare each data point to the mean. And we said that compare means subtract. So we're going to take each one of these values and subtract the mean. 5 take away 15, 10 take away 15, 20 take away 15, 5 take away 15, and 30 take away 15. 1, 2, 3, 4, 5, 6. What am I missing? Oh, I forgot a 15. Mistakes are fine. 15 take away 15. 20 take away 15. Sometimes I think the hardest part of this is transferring the numbers. 25 take away 15 and 30. All right, so if I subtract all of these values and get myself a list, this is going to be a list of how far each value is away from the middle. And I'm going to write those values down. You should double check and make sure I'm doing this right. And again, if you're following along, then when you're done with this, you're going to have some good notes that you can reference. All right, so these are the values that I get. Each one of these is how far away from the middle are you? Now, we said the definition for standard deviation is, on average, how far are you away from average? So theoretically, we should be able to add these all up and divide by 7, and that would tell us, on average, how far we are away from the middle. And that's all well and good, except for something happens when we add all these up. Let's take a look what happens. It's kind of tricky. If we add all these up, notice something. Notice that like we have opposites, 15 and a negative 15, negative 10 and 10, negative 5 and 5 and 0. If we add all these up, we're going to end up with 0. Everything's going to cancel each other out. And it actually kind of makes sense when you think about what the mean is. Saying, okay, all of these values are going to work with or against each other till you get to the middle. So some are going to be bigger, some are going to be smaller, and then you're going to end up in the middle, and they end up canceling each other out to get to the middle. It's kind of saying, if everyone had the same, how much would they have? Well, they'd all have 15. Some would have more, some would have less. But in the end, they'd be 0 away from 15. So this is a problem. We can't add them all up to find, on average, how far are the points away from average. So we're going to do something, all right? Because we have some negatives and some positives. The problem here is that we're looking at direction as well as distance. And when we're talking about, on average, how far are we away from average, we don't actually care about the direction. We really just care about the distance. So we want to know, some are less than the middle, some are more than the middle, but we don't want to know which direction they're going. We just want to know the distance away from the middle. So the negatives are what is the problem. All right, so we were going to have to adjust this data set so that we can get rid of the negatives, and then we should be able to compute an average. But you can't just drop negatives just because you feel like it. And you can't manipulate one part of the data set without doing the same thing to the whole set. We are allowed to manipulate the data set, however, and this is how we're going to do it. This is kind of part C. You ready for this? This is a very clever thing. We're going to take each value. These are called deviations, by the way. These are called deviations. Just means how much does each value deviate from the middle. We're going to take each one of these deviations and we're going to square them. So 5 squared, 0 squared, 5 squared, 10 squared, 15 squared. If you don't put them in parentheses and you try to square it on your calculator, your answer will be negative, which will defeat the purpose. So just remember, this is a negative 15 times a negative 15. If you don't put it in parentheses, you might get 15 squared and then your answer will be negative. But if you put it in parentheses first, it'll make sure and square a negative 15. Regardless, when we get squared values, this is what we end up with. 225, 100, 25, 0, 25, 100. Notes are coming. And what do we have? 225. I'm going to just turn off my notifications so that I don't get any. Let's see, focus, do not disturb. There we go. Then I won't get any embarrassing texts. Here we go. We've got a bunch of values squared. And now you'll notice, right? We know we have the same values, like a negative 15 squared is 225 and a 15 squared is also 225, but they're not going to cancel each other out now, which is fantastic. So this list of values also has a name. This is called the squared deviations. Squared deviations. And it's because we took every kind of difference from the middle and squared it. And now something beautiful is going to happen. This is kind of step D. Is we're going to add up all of these values. Add up our squared deviations. Because remember, we're shooting to get the average. So the average is always add them up, divide by how many there are. We had to square them to get rid of the negatives, but now we're going to add the squared values up and divide by how many there are. So let's add up the squared deviations. And that value, when you add all these things up, in this case, is equal to, so let's do this, 225 and 100 and 25 and 0 and 25 and 100 and 225 is all equal to 700 when you add them up. I hope. I believe that's right. Okay, so we've got steps A, B, C, and D so far. And I know it looks like a lot of messy math, but really we're not doing any difficult calculations. We just have to do it over and over and over again. All right, so let's see, next. Here we go. We just added things up. That was step D. We squared the deviations, added them, so now we're on step E. When you have the number 700, you're going to take your sum, we call it the sum, which just means adding, of the squared deviations, which is what we had to do to get rid of the negatives. Take the sum of the squared deviations and divide it by how many data points there are. Just like you would do with the average, because we're kind of taking an average, right? How many data points there are. So in this particular case, we said the sum of the squared deviations was 100. Nope, that's not true, 700. Sum of squared deviations is equal to 700. And we said that there's 7 numbers. So we're going to take, in this step, the 700 and divide it by 7. All right, and then we're going to get an answer of 100. We're almost there. We're so close. What does this 100 mean? Well, this 100 is actually the average squared deviations. So this 100, we're like, okay, we're so close, but the 100 doesn't actually mean anything to us. Actually, this has kind of a fun fact. This has its own name. It's called the variance. But we're not going to use the variance. We want the standard deviation. So we have one more step. This number isn't taking care of the fact, like, we squared all of the data values. Like, if our data values were money, now we're dealing with money squared. that doesn't mean anything to us. So we have to undo, our last step is essentially to undo the square. And do you remember how to undo a square? Hopefully you remember undoing a square requires you to take the square root. So we are going to take the square root of our answer from part E. And remember, we call this the variance. That's kind of for free. You get that little piece of the variance. So take the square root of our answer from part E, also called the variance. And if you do this, you will end up with the standard deviation. The square root of the variance is a standard deviation. So here we go. You ready? Last step. We're going to take the square root of 100, and that's going to give us a value of 10. Square root of 100 is 10. So we took this square root of 100, we got a 10, and that's our standard deviation. That is actually the answer we've been looking for, and it has a meaning. Standard deviation, yay, we did it. Standard deviation, yay. Woohoo, what does that mean though? Well, do you remember our data set? We said, all right, first of all, we knew the middle was 15, okay? And some things were less than the middle. So we had 0, 5, and 10 that were kind of less than the mean. Then we had the middle, which was 15. Then we had what was higher than the mean, 20, 25, and 30. Those were our three higher values, right? So the standard deviation says, on average, how far are you away from the middle? Well, what's 10 less than 15? We said we have a standard deviation of 10. 10 less than 15 is 5. So this is a distance of 10. And then we could also go the other direction and say, okay, 15 plus, this isn't to scale very well, so let's see if we can fix this real quick, just to make it look more evenly spaced. So we said 20, 25, and 30. And then if we take this scale here, this is also a size of 10 because those are the deviations. And it's saying most of the values will fall within 10 of the middle. And we said the middle was 15. We know that this is our middle. That's why this is a special number right here. Woohoo! And most of the values, and you can see that that's true, that most of the values will fall within 10 of the middle. And that is the standard deviation. And we love the standard deviation. We love the standard deviation because it keeps track of every data point. It uses every data point, not like the range, which only uses biggest and smallest. We love the standard deviation because it takes every data point into consideration. And the standard deviation helps people find the truth about a data set, because when you're using statistics, you're summarizing data sets. You're not giving everyone all of the values. So you could say, you know, oh yeah, we have an average salary here at this company, $50,000 a year. Well, one person could make nothing and the other person could make $100,000, and you know, you would have an average of $50,000. That's true. But the standard deviation says, okay, well, on average, how far are you away from that 50,000? Right? If everyone was making $50,000, you wouldn't even have, you'd have a standard deviation of 0. You'd say everyone's making 50,000. But you know, if you're deviating in either direction from the middle by high amounts, you can't hide that when you use the standard deviation. So you get a really good summary if you use the standard deviation and the mean as your kind of statistic. So we love the standard deviation because it takes every data point into account. And then last but not least, if we could write those steps, kind of like A, B, C, D, E, F. So let's see. We know that F was the square root. That's the square root to find the standard deviation, right? And then here we, let's see, I think step A was that we find the mean. Step B was what? Find the deviations. Step C was square the deviations. Step D was sum the square deviations. Oh, that's the kitty. Sum squared deviations. What? You have to wait till I'm done with math. Find x bar, find the deviations, square the deviations, sum the square deviations, and then find the variance, which is kind of like the average of the squares. All right, kitty, kitty. Find x bar, find the deviations, square the deviations, sum the square deviations, find the variance, and then take the square root of the variance to find your standard deviation. Feels like a lot of steps, but like I said, when you go through it little by little, it's not hard math, it's just a lot of tiny computations. So now you understand, hopefully, what a standard deviation is doing